Right. Picture this. You're at the pub, minding your own business, and some bloke starts loudly explaining to anyone who will listen that human beings couldn't possibly have evolved in Africa. His grand argument: it's stupid to say we originated in the African Savanna, mate, because look at us. We aren't evolved for the dry bushlands. He then takes a smug sip of his pint, utterly convinced he has just dismantled 150 years of paleoclimatology, genetics, and evolutionary biology with a single sentence. It is incredibly frustrating to listen to, primarily because this argument completely misunderstands what the ancient African climate actually was, how biological adaptation works, and what the fossil and genetic records explicitly prove. So let's properly dismantle this pub logic. We're going to look at the Milankovitch cycles, the brutal biological receipts of our own anatomy, and exactly how we know that humanity's family tree is firmly planted in African soil. The bloke in the pub is making a massive foundational error right out of the gate. He assumes that the Africa of 300,000 years ago looked exactly like the Africa you see on a David Attenborough documentary today. When people hear the words African savanna, they picture an endless bone-dry desert. But the Earth's climate is not static. It is governed by Milankovitch cycles, massive, predictable changes in the Earth's orbit, and axial tilt that drastically alter global weather patterns. Every 20,000 years or so, the Earth's axial precession, its wobble, shifts the West African monsoon system significantly northward. When this happens, the Sahara desert completely vanishes. We call this the African humid period. Around the time Homo sapiens were first emerging, the Sahara was a vast, lush, tropical biosphere. We have found fossilized hippo teeth, crocodile bones, and ancient fishing hooks in the absolute dead center of what is now the most arid sand dune in the world. There were massive bodies of water, like Lake Megachad, which was larger than the modern Caspian Sea. Furthermore, evolutionary anthropologists don't define the ancestral savanna as an endless dry desert. They define it as a mosaic environment. It was a patchwork of dense riverine forests, seasonal wetlands, open woodlands, and grassy plains. Early hominins didn't evolve in a uniformly harsh wasteland. They evolved in a wildly fluctuating ecosystem that was constantly shifting. And that constant environmental chaos is exactly what forced us to evolve. The second massive flaw in the pub argument is a misunderstanding of what evolution actually does. The bloke thinks that if we evolved in a hot environment, we should look like a camel or an antelope, perfectly specialized for one exact biome. But evolution doesn't design for perfection, it designs for survival. Humans didn't adapt to sit peacefully in the dry bushland. We adapted to dominate it through sheer endurance. Around 2 million years ago, the African climate began a long-term drying trend. The dense forests shrank, creating wide open spaces. Our ape ancestors had a choice: cling to the shrinking trees or cross the open sun-baked plains to find new food. We chose the ground, but crossing the savanna during the day is incredibly dangerous. You overheat quickly. So, how did our bodies respond? Bipedalism and solar radiation. Standing up on two legs wasn't just to see over the tall grass. According to thermoregulatory models, walking upright reduces the surface area of your body exposed to the direct overhead sun by up to 60%, while exposing more of your torso to cooling breezes. The nuchal ligament and Achilles tendon. If you look at the fossils of Homo ergaster, like the famous Turkana boy from 1.5 million years ago, you see the development of the nuchal ligament at the back of the neck, which stabilizes the head when you run. You also see a massive Achilles tendon, which acts like a biological spring. Apes don't have these. These are explicit adaptations for long-distance running. The sweat engine. We dropped our thick body hair and multiplied our eccrine sweat glands. We have between 2 and 4 million of them, We are, by a massive margin, the sweatiest mammals on Earth. We aren't unsuited for the hot bushland. We are arguably the most highly evolved thermoregulatory machines on the planet. This anatomy allowed early humans to invent persistence hunting. We could track an antelope during the absolute hottest part of the day, literally jogging it to death through sheer heat exhaustion, while other apex predators were forced to sleep in the shade. All right, we've sorted out the climate and the biology. Now, let's look at the absolute irrefutable hard evidence, paleontology. If humanity originated somewhere else, let's say Europe or Asia, we would expect to find the oldest transitional hominin fossils there. We don't. We don't even find anything close. Every single piece of early transitional fossil evidence points straight back to Africa, and the timeline is staggeringly clear. 7 million years ago, Sahelanthropus chadensis is found in Chad, showing the very first hints of an upright posture. 4.4 million years ago, Ardipithecus ramidus is found in Ethiopia. Her skeleton proves that bipedalism actually started in woodland environments long before our ancestors moved out onto the open plains. 3.2 million years ago, Australopithecus afarensis, Lucy, is walking fully upright in East Africa. 2.4 million years ago, Homo habilis, the first tool makers, emerge. And then we get to us, Homo sapiens. For a long time, scientists thought we evolved in one specific spot in East Africa. But deeper research has revealed something called the Pan-African evolution model. We have found the earliest undisputed fossils of our exact species at Jebel Irhoud in Morocco, dating back 300,000 years, and Omo Kibish in Ethiopia, 230,000 years ago. This proves that modern humans didn't pop up in one single valley. Different populations of early humans were spread across the entire African continent, interbreeding, trading technologies, and slowly coalescing into the modern human species we are today. If the fossils don't convince the bloke in the pub, the DNA will. You don't even need to dig up ancient bones to prove the out of Africa theory. You just have to look at the blood running through your veins right now. In genetics, there is a concept called heterozygosity, which is essentially a measure of genetic diversity within a population. Whenever a small group of people splits off from a main population and migrates somewhere new, they only take a tiny fraction of the group's total genetic diversity with them. This is called a founder effect. Every time that new group splits and migrates further away, the genetic diversity shrinks again. When geneticists map the DNA of every living human on Earth today, they find a massive, glaring mathematical truth. There is vastly more genetic diversity within the continent of Africa than in the rest of the entire world combined. Two individuals from two different indigenous populations in sub-Saharan Africa are frequently more genetically distinct from one another than a British bloke in a pub is from an indigenous person in South America. Every single human being walking around today whose ancestors live outside of Africa, whether you are European, Asian or Polynesian, belongs to a genetic lineage that is just a tiny recent branch off a massive ancient African tree. Through mitochondrial DNA passed from mothers and Y chromosomal DNA passed from fathers, we can trace every non-African lineage back to a specific migration event that left the African continent roughly 60,000 to 70,000 years ago. As you move further away from East Africa, across Asia, down into Australia, and over the land bridge into the Americas, human genetic diversity decreases linearly. It is a perfect mathematical breadcrumb trail leading right back to the source. Science doesn't rely on pub logic or what feels right based on looking at a modern city dweller. We build models based on hard data. The fossil record demands an African origin. The genetic data mathematically proves an African origin. And our own bipedal, sweaty, heat-dumping bodies are the biological receipts of a species forged in the African sun. We didn't evolve to be specialized for a single dry patch of grass. We evolved in a rapidly changing, geographically chaotic mosaic environment that forced us to become the most adaptable, clever, and resilient generalists this planet has ever seen.